Today we will review how to perform reflections, rotations, translations, and dilations. So all of the basic transformations. But before we get started, there are a handful of rules that I need you to memorize. These are the 4 rules for reflections, and these are the 4 rules for rotations. The 3 rules for rotations. If you don't already have these memorized, you need to pause the video right now and write these down and practice writing them down until you can write them down from memory. So for the rest of this video, I'm going to assume that you have these 7 rules absolutely memorized. All right, so make sure that that is true. All right, so problem number 1. This point is translated to become the other point. And we're being asked which one of these things happened. Well, let's see. The x value went from 8 to 1. So that means that it decreased by 7. The y value went from I feel like I should change colors now. The y value went from -2 to +3. From -2 to +3, that is an increase of 5, if you think about it. -2 plus 5 would be 3. So that means that the y values increased by 5. Okay, so that means left 7 and up 5. And that is C. All right, looking at problem number 2. This rule is applied to this point. By the way, this is a 90-degree counterclockwise rotation. So have these rules memorized to the point where you can recognize that. But anyway, that's not what they're asking us. They're just saying apply the rule to this point. Okay, so this says opposite of y, x. The opposite of y is +2. And then x is simply 4. So this should be the answer. All right, so that means the answer is D. But let me stop and emphasize this for a second. Notice how you hear me say opposite of y instead of saying -y. If you say -y, you're going to be tempted to put a negative sign right here. If you say the opposite of y, it reminds you to look at the y value and then write the opposite. So if it is already negative, it has to become positive. And that's what happened here. Problem number 3. A transformation changed point K into K prime. Now, which transformation is it? All right, let's think about it. So let's start by looking at the x value. The x value went from -3 to +3. So first of all, did it stay first? Yes, the x value stayed in the first spot. Now, did it stay the same or is it the opposite? Well, it went from -3 to +3. So that's the opposite, so I need a negative sign right here. Okay? Now, again, in a rule, this minus sign means opposite. So it doesn't matter that this is a +3. It's the opposite of what it was, so the rule will have a negative sign. And then the y value, let's focus on that. 4 became -4. So again, that is the opposite of what it was. So that's going to be the opposite of y. Okay, so opposite of x, opposite of y. Okay, that's right here. Opposite of x, opposite of y. That is a 180-degree rotation. So that's why the answer is A. Okay, problem number 4. Which of the following rules represents a horizontal stretch? As soon as you see the word horizontal, the horizontal is in the x direction. So that means only the x values should be affected. So we know that it's not going to be A or B because that's y values. So it's going to be one of those. Now, when you see that it is a stretch, that means that the number in front has to be bigger than 1. And 7 over 4, that's the one that is bigger than 1. If the numerator is bigger than the denominator, then the fraction is bigger than 1. Okay, this D would have been a horizontal shrink. Okay, what transformation has been applied to triangle LMN? So look for the reflection line. All right, where is the mirror line? So right in between these two triangles is a vertical line right here. Now, vertical lines have the equation x equals something. So this vertical line is at the number 1. So this is the line x equals 1. So since this is the reflection line, then we would say that the triangle was reflected over the line x equals 1. So that's why the answer is B. All right, notice that even though the x-axis is horizontal, the line x equals a number is vertical. So it's kind of the opposite of what you would normally think. All right, number 6, what transformation happened here? Well, look for the reflection line, and hopefully you can see that the reflection line is right here. Do you see how this diagonal line splits the image right down the middle? Now these are mirror images of each other over the diagonal line. But a diagonal line like this is the line y equals x. If it went downhill, it would be y equals negative x. So this is a reflection over the line y equals x. So that is going to be C. Which transformation would map the triangle onto itself? When you talk about mapping something onto itself, especially when you're talking about reflections, then what you should be paying attention to is that you're looking for a line of symmetry. So look for a line that splits the triangle right down the middle. And hopefully you can see that this diagonal line, see how that splits the triangle right down the middle so that we have a mirror image on either side of the line. But a diagonal line that goes downhill is called y equals negative x. So this is a reflection across the line y equals negative x. So the answer is B. All right, which rule represents the transformation that is shown here? Okay, so I can tell by the choices that we're definitely talking about a translation where this triangle has been slid over to the left and down. Be careful. Notice how this point where I just put the red dot, this is J, and this other point is J prime. The prime is the one that comes second. The one without the prime is the one that is first. So we have to start here at J, and we have to decide what happened. So the pathway seems to be like this. It went left this many, okay, and that is 6. So it was left 6, and then it is down 2. All right, so left 6, down 2. All right, left 6, down 2, that's what's happening in D. Left 6 is x minus 6, down 2 is y minus 2. All right, number 9. Draw the image of segment PQ after it's rotated 90 degrees clockwise. Okay, let's use the rule. So when you're talking about 90 degrees clockwise, the rule for that is y opposite of x. And again, we are just grabbing that off of our chart. Okay, y opposite of x. So let's see. The original points are P, which is -2, 4, and Q, which is -4, 0. So now P prime, we will use the rule y opposite of x. Y is 4. The opposite of x is +2. Let's do the same thing for Q prime. Again, we're doing y opposite of x. Y is 0. The opposite of x is +4. So 4, 2, all right, that'll be P prime. And 0, 4, that will be Q prime. Okay, that's it. Number 10. Draw the image of segment PQ after it is reflected over the line y equals -1. Remember, y equals a number is horizontal. Right? That you just have to memorize. So we're talking about a horizontal line at -1. Okay, so this is the line y equals -1. So let's just do this visually. See how Q is 1 above the line, so Q prime will be 1 below the line. So this is my Q prime. Now P is 5 above the line, so P prime will be 5 below the line. So that's it for number 10. Dilate segment PQ from the origin by a scale factor of 3/2. Then reflect PQ over the y-axis. So we're going to do 2 transformations in a row. Okay, so let's start with writing down the coordinates of P and Q. All right, so we're going to start with P, which is -2, 4. Okay, and we're going to start with Q, which is -4, 0. All right, these are the original points. So the first thing I'm going to do is dilate by a scale factor of 3/2. Whenever you do a dilation, when it says dilate, you're going to multiply both numbers, okay, the x and the y. So what I have to do is, I'm going to have to do 3/2 times -2, and I'm going to have to do 3/2 times 4. All right, I'm going to have to multiply both of these. But let's see. So this is going to be like, it's a -2/1. So this is going to make -6/2 and 12/2. But now I can come up here and say, all right, so P prime is going to be negative 3, all right, because negative 6 divided by 2 is negative 3. So I'll have negative 3, comma 6. All right, so that's the dilation. Okay, so let's see, negative 3, comma 6 is going to be right here. So that's going to be P prime. All right, now let's talk about Q prime. All right, same deal. I need to multiply by 3 over 2 again. So that means I'm going to do 3 over 2 times negative 4 and 3 over 2 times 0. Well, this is going to make negative 12 over 2, and anything times 0 is just 0. Negative 12 divided by 2 is negative 6. So then I have negative 6 comma 0, and that is Q prime. Negative 6 comma 0, so that's going to be right here, and that is Q prime. All right, next I need to reflect across the y-axis. Okay, so I'm going to reflect across the y-axis. Now, when you do this reflection, the rule is that it's going to be the opposite of x, comma, y. So, oh, you know what? I forgot to draw. One moment. I forgot to draw the line, and it's beginning to bother me. Okay, so there is the segment after the dilation. Okay, so I could use the rule if I wanted to. So if I want to find P double prime, which is what you call it when you do a second transformation, I could just do opposite of x, comma, y. Opposite of x is 3, and then y is 6. So this will be 3, comma 6. So 3, 6 would be right here. All right, I also could have done it visually because we are reflecting over the y-axis. P prime is 3 to the left, so of course P double prime will be 3 to the right. So I didn't really need the rule just then, but it doesn't hurt. All right, I could do the same thing with Q prime in order to find Q double prime. If I use the rule, opposite of x, y, the opposite of x is going to be positive 6. The opposite of 0 is still 0. Sorry, we're not doing the opposite of y. We just put the 0, so it doesn't matter. It's still 6, 0. So 6, 0 would be right here. So this is going to be Q double prime. And again, we could have done it visually by noting that Q prime is 6 to the left, so Q double prime will be 6 to the right. Oh, I probably have to change this. So that is the final answer. So this red is the final answer. Technically, you didn't actually have to draw the purple one at all. If you were going to just use the rules the whole way, you could have just done the writing part, and then you would have gotten these red answers, and you could have just plotted them without showing the purple part. Number 12. The point J, which is 12, 6, is stretched vertically by a scale factor of 3. As soon as I see vertically, that tells me that we're talking about a change to the y values. Y values only. So in other words, we're going to keep the x value the same, and we're going to multiply the y value by 3. So in this case, we're going to keep the 12, but 3 times 6 is 18. Only the y value. And that's it. Okay, that was pretty easy. Now this point is rotated 90 degrees counterclockwise. All right, so we have to remember that the rule for that is opposite of y, comma, x. All right, and this is why it's so important to memorize these rules. Here we have 90 degrees counterclockwise, opposite of y, x. But that has to be in your head. So let's see, the opposite of y is going to be -6. And then x stays whatever it is. And x is -4, so it just stays -4. Again, notice that just because this x doesn't have a negative sign on it, that doesn't mean that this is going to be positive. All right, this x means just keep x whatever it is. So if x is -4, then it stays -4. All right, number 14. We are reflecting across the x-axis. The rule for that is x opposite of y. All right, again, I'm just glancing that right from the rules. X opposite of y. All right, make sure you have that memorized. So x is 2, and the opposite of y is -9. All right, number 15. This point is rotated 180 degrees around the origin. Okay, 180 degrees. The rule is opposite of x, opposite of y. So the opposite of x is 5. And the opposite of y is -2. That's it. Number 16. We are translating to the right 10 units and up 8 units. So that means we're going to take any x value and we're going to add 10. All right, that's how you do right 10. And if I want to go up 8, that means I need to add 8 to the y value. So, okay, I'm adding 10 to the x value, and I'm adding 8 to the y value. So 7 plus 10 is 17. And 15 plus 8 is 23. So that's number 16. Fill in the blanks to describe the two transformations that would map this rectangle onto itself. When they talk about mapping something onto itself, they are talking about lines of symmetry. At least when you're talking about reflections, it has to be a line of symmetry. So what would be a line of symmetry for this little picture? So there's one line of symmetry that's going to be right here. Can you see that this line splits the rectangle right down the middle? A vertical line actually has the equation x equals something. So this is the line x equals 2. So a reflection across the line x equals 2 will reflect the image, will map the rectangle back onto itself. All right, the left side would fall onto the right side, and the right side would fall back onto the left side. And in the end, it would still look the same. Okay, but there is another line of symmetry, which I will mark in green. There's a horizontal line of symmetry right here. Can you see how this green line splits the rectangle right through the middle? Horizontal lines have equations of the form y equals a number. So this is the line y equals -3 because it's at -3. So reflecting across the line y equals -3 will map the rectangle onto itself. Okay, this one has rotations in there also. Okay, so we got to be careful about that. So let's start with let's start with the lines of symmetry, because those will give me the reflections. Okay, so let's see. So this vertical line splits the image right down the middle. But that is the y-axis. So that means a reflection over the y-axis will map the diamond back onto itself. But that's not all. What about horizontal lines? Can you see that this horizontal line also splits the diamond right down the middle? All right, same on the top, same on the bottom. But that is the x-axis. So that means reflecting across the x-axis will also map the diamond back onto itself. Okay, the next one is trickier and it's going to fool some people. The line y equals x is this diagonal line that goes like this. All right, at a glance, you might think that these are mirror images of each other, but they are not quite mirror images of each other. All right, for example, look at this point right here. All right, see how this point is one diagonal square away from the line? If I go one diagonal square to the other side, it would be right there. All right, not way down here. No. Okay, so these sides are not mirror images of each other. All right, it's the same if you look at the other corner. I'm trying to control Z, but it's not working. So let me just use my eraser. Okay, for one more example why this is not a mirror line, it's not a line of symmetry. Look at this point right here. All right, and look for the reflection of it. Is there anything there? All right, diagonally, this point is 2 diagonal squares away. If I go 2 diagonal squares on the other side, I'm going to be here. But notice there is nothing there. So this diagonal line is not a mirror image. And for the same reason, the line y equals negative x will not be a line of symmetry either. So we're not going to circle either of those. Now let's talk about rotations. A 360-degree rotation means that you rotate the figure all the way around and back to where you started from. So of course the image will look the same as long as the origin is right in the middle of the picture, and it is. So a 360-degree rotation will definitely work. Okay, what about a 180-degree rotation? Well, a 180-degree rotation means turning the picture upside down. Will that work? Okay, well, let's see. Maybe you can just tell at a glance that yes, this is going to work, but I'm going to try to make it a little bit more clear. So there's the top half, and now I'm going to change colors a little bit. Switch to green for a second for the bottom half. Wait. Okay, so I've sort of traced my diamond here. So now 180 degrees would mean that I'm going to turn this thing upside down. So let's see what happens. I'm going to use my rotation tool. And there is no 180 degrees, so I'm just going to rotate it 90 degrees twice. By the way, maybe I'll pause right here for a second. So far I did 90 degrees clockwise. Can you see that it does not look the same? It's not falling back on itself. So I know that I'm not going to circle 90 degrees clockwise. Okay, but I'm going to rotate again. All right, I'm going 90 degrees clockwise again. So now that's a total of 180 degrees. Notice that it falls back on itself again. So a 180 degree rotation does map the figure back onto itself. So that should be circled. But not 90 degrees clockwise. What about 90 degrees counterclockwise? What if I did this right here? All right, well, I think it's going to be obvious to you that that will not work. But I can show it. So if I rotate this 90 degrees counterclockwise, the green part should be facing to the left. So let's do that. So I'm going to rotate 90 degrees, and counterclockwise is like to the left. So there I've rotated 90 degrees counterclockwise, and you can see that they do not match. So these are the four that work. Okay, number 19. Hold on, let me grab a marker. So this point is reflected across the y-axis and then translated left 3 units. Okay, so we're going to do this in stages. So let's start by reflecting across the y-axis. The rule for that is opposite of x, comma, y. So the opposite of x would be -5, and then y is -4. Now we're going to translate left 3 units. Well, left 3 units would be x minus 3 and leave the y alone. So I'm going to do x minus 3 and leave the y alone. -3 and -5 make -8. And then I still have the -4. So that is the final answer. So let's try that again. Let me switch back to purple. So we're going to rotate 180 degrees around the origin. So the rule for that is opposite of x, opposite of y. That's the rule for 180 degrees. So let's do that. Opposite of x is -3. Opposite of y is -8. Okay? Now we need to reflect across the line y equals x. But the rule for that, okay, reflecting across the line y equals x, that's yx. So y is -8 and x is -3. And that is the final answer. All right, finally, we are at the bonus question, which is last. On the grid below, draw a shape with at least 3 sides so that the shape would be mapped onto itself by all of the following transformations. Okay, these are all reflections. So that means these all have to be lines of symmetry for whatever we draw. So I think it would be a good idea to draw these lines of symmetry. Okay, I got to choose my colors wisely. I think I'll start with blue. All right, so I'm going to use blue for this one. So x equals -3. This is a vertical line at -3. So this has to be a line of symmetry for whatever I draw. Okay, now I need another line of symmetry. This next one I'm going to do in green. Okay, y equals 3 is a horizontal line at 3. So that means this has to be a line of symmetry. And the last one I will do in pink. y equals negative x is a diagonal line that goes downhill. So this is the line y equals negative x. All right, so whatever shape I draw, it has to be, all three of these lines have to split the picture right down the middle. All right, so let's be careful. All right, let's see if I can do this. So I'm going to take this one line of symmetry at a time. So let's start with this diagonal line. So, okay, if I draw a segment from here to here, see, why didn't it draw anything? Okay, let me try that again. If I draw a segment from here to here, so far that is symmetric over that line. Okay, now whatever I draw next has to be it has to be symmetric over the blue line. Okay, so how about if I do like this? Okay, how about if I go like this? All right, now I'm looking at the blue line. Okay, so far, so good. Okay. Look at this picture. So the question is, will this do it? So does the pink line split this square, actually? Does it split the square right down the middle? The pink line seems to work. All right, I'm going to have this, the part on this side and the part on this side are identical. How about the blue line? Does the blue line work? Okay, so look at this side. Okay, and then look at this side. All right, those are identical as well. Now, how about the green line? Does the green line work? All right, look at this. All right, on that side of the green line, and then look at this. All right, so all three of these lines are lines of symmetry. So reflections across any of these lines will map the figure back onto itself. So this is one answer. This is certainly not the only answer. There are other ways to answer this question, but this is one way that would